Hello everyone, this side is Rishabh and we will be having a session today on trees, trees and tree traversal. So let me share my screen with you. Okay, so today's session will be on trees and trees traversal. So let's before going further, we will be telling you what coding club is. So coding club is coders community across 750 plus engineering colleges in India, and in our community we have colleges. Along with that, we have mentor team, alumni team, and growth hacking team. So let's start today's session, and we will be learning what tree data sector is. So firstly, let's discuss what tree data sector is. So this has been answered on Quora in a very great way. So let's say what is linked list? Linked list is a chain of nodes connect through next pointers. So like this is connected to this and this is connected to this. Then this will be called a linked list. But a tree is okay. But a tree is when we walk through a tree. Mostly we mean binary tree. This is the data structure that two children and left and right. So what is a tree? So tree will have more multiple nodes connected to it, not just one single node. So tree is similar, but each node is connected to multiple nodes. So what let's see what binary tree is. So first we will gonna be learning binary tree. So this is a binary tree. So this is a one node for which we have some data. This is called root where it starts, and for each node we have either two children, max to max two children we have in the binary representation tree. So how do we define a tree? So tree is something like, let's say we made a structure in C code, struct node in data. In data, every node will have some data in it. So we have three nodes over here, and each node will have two pointers so that it can save the address of this node as well and this node as well. So each node will have these three data points. So let's say we want to build this. Let's say this kind of tree we want to build. How do we build? And if there is no child, then it will be pointing to null. And there is no child, then we will be pointing it to null. So now let's come back. We want to create this tree. So how do we create this tree? Let's say we want our data to be 1, and in the data of 1 there is a left child with a node value 2 and there's a right child with a node value 3. So how do we create? So first we named star root. So root is a pointer which can save the address of the top. We want to save the address of this top node, so we pick one root, and then one for the first node, for the second node, and for the third node. We took three addresses so that we can point them. Now, what we are doing here, we are allocating memory. So memory is allocated by a malloc, or if you are using C++, you can use new struct node. So, but here we are doing it using malloc, and then we are filling the data that one data is one, the pointer which is the node which is pointing to 2, the data is 2, the node which is pointing to 3, uh, is data is 3. So again, then what we did, we connected the nodes. Now one left of one should left in the left of one there should be 2, and in the right of one there should be 3, and similarly we also initialize all the 4 pointers as null which were not there. So once we write this code and execute it, we're gonna get this. I hope all of you understood till now, so that we can start working on problems as well. Can you comment if you understood till now, or you can ask doubts as well? So, do you have any doubts till yet? Okay, so Vignesh has some doubt. You can ask your doubt, Vignesh. So let me draw it on sketchpad so that you visualize very easily. So a tree is something like this, in which one node can point to another node. So let's say this is node 1, this is node 2, this is node 3. In the linked list, we have something like this, and this is called head. And let's say this is pointing to nothing, then we call it tail. So this is linked list, but this is tree. This is called root. And if we have more children, let's say more children, we call these nodes as, which do not have any child, we call them as leaf node. So this is a leaf node, this is a leaf node, and this is a leaf node. And if there is one child of this node, then it will not be a leaf node. And let's say this is a node, now this will be a leaf node, but this will not be. So this is what tree look like, because here we have at max two children. So we are calling this tree as binary tree. That's why we are calling it as binary tree. But if we have a tree something like where we have more than two nodes, something like that, then we call it as a tree. Or we also can call it as uh, a multi-array tree. Okay, leave it. We call it as multi-array tree. So this is binary tree we are discussing about. So we will be starting discussing binary search tree. So what binary search tree is? So let's say we have some data to be added. Let's say 100 is there, 20 is there, 8 is there, 200 is there, and 50 is also there, and 60 is also there. So let's say this is the data, and we want to search the data as well. So let's say we have this data, and we have 6 elements in total. So to search a particular data, we will be taking 6 steps: one, 2, 3, 4, 5, 6. Let's say we want to check whether there is 100 in the data or not. We will be taking 6 steps. Let's say because for 200, the match will be at the sixth position. So on an average, we will be taking order and complexity to search element. Okay, so let's come up with a better data structure which will gonna make it easy to search. So let's say we inserted a 60 in the tree, and we have a rule: if the value is less, it will go in the left, and if the value is greater, then it will go in the right. So now the next number is 50. Because value is less, it will gonna go in left. Now 100 came, because it is greater, then it will gonna go in this direction and add itself. So when 20 came, because it is lesser, it is lesser, it is lesser. 8. Lesser, lesser, lesser. So it will gonna come here. 200. So 200 will gonna come here. But let's say 150 was also there. Now it will gonna come here because it is greater. Now it is even greater. It will gonna come here because it is lesser than 200. Then it will gonna go here. So this will be the binary search tree. So this is what we learned just now. So now let's say we want to search 150. How many nodes? Let's say we want to search 100. How many steps you gonna take? Can you comment? If we are searching in this, and if we are searching in this, so can you tell how many steps we will be taking on an average? So let's taking this example. Let's say we want to search for 200. So how many steps 200 will gonna take for the array, and how many it will gonna take for this tree? Yeah. So in the tree, as we can see, there will be log n number of node if tree is balanced. So let's say 3 and 6. So it's correct. Basically, let's say we have lot more data. Let's say the tree was big. So now we can see we have total number of nodes is 1 plus 2 plus 4 plus 8 plus 16. So which will be 31. So let's say we had an array of length 31. If we are searching a number, let's say, which is in the middle of it on an average, so at n by 2 position, we will gonna be doing order n by 2 if we want to search for it. So we will be taking order of n. But in tree we can see for the 31, if we take log of 32 base 2, we are getting 5. So at worst case, we will be making just 5 comparisons. First, we will gonna come here. At the second step, we will gonna decide whether the value is lesser or greater. We will gonna come to this node or this node. Then coming on this node, we will gonna this level. We will gonna decide to pick this or this or this or this based on the previous decision. Let's say previous decision was this. Then we will gonna pick this or this. So at third step, we will be here. And in the fourth step, let's say we reached here. And then we reached here. So in the fifth step, we will be able to find whether this particular number is in the tree or not. So which is taking order of, so binary search tree, for binary search tree to search, the complexity is log of n. Oops. Okay. So we will be solving one question on this binary tree. Before going further, let's come back to presentation. So what are the applications of trees? So binary search tree, as we just discussed, are very easy to check whether element is there or not. And there are a lot more use of trees. It is being used in databases. So we have more and more, uh, you can say, tree is also used in recursion. When you make, like, you can say, let's say you want to draw a fractal. So the when we have a no, let's say you want to make a data structure which is called try is based on phone dictionary. Let's say you want to search someone's number in the phone dictionary. So you just type few numbers, few prefix, and the name suggestions comes. So this is being used by tree concept of try as well. So we will be discussing try as well, but before going further, we will be solving some questions from the lead code. So let's open lead code. So let's start with this question, which is called same tree. So let's say you are given two binary trees and you need to write a function whether they are same or not. And two binary trees are considered same if they are structurally identical, and nodes have the same value. So if the values are same, because the values are same and the structure is also same, this is a same tree. Then we are returning a true. But if let's say this was here and the value was 2 and there was no child here, so structure is different, all the values are same, so we will be returning output false. So we need to just verify whether the two trees are same or not. So if they are same, then we need to print same. So let's think about when do we decide that whether the tree, both of the trees are same. How do we decide that? So let's take a new sheet. So let's say we have some two trees, something like that. There is a left subtree, right subtree, and there is one more tree we are comparing with. So there is a left subtree, there is a right subtree, and this is tree A and this is tree B. So if the value of these two is not same, if values are same, then it's okay. If values are not same, then we can say return false. But if values were same and they were, both of them were not null, if values were same, then we just need to check whether the same problem we need to solve with this. So let's say we were calling this function as f. Let's say we named the function as instead of f, is same. We have a function, let's say is same, and we passed a and b into it. Now to solve this, we checked this, and if it was same, then we were saying we need to check the subtrees as well, else we are returning a true. Now at this point, what we will do, if they are same, then return whether left sub left subtree of this, the left part of a, whether a left is as same as left of b. We will be calling the same function is same. I do not have space, so I'll be writing it here. It's same. We will be calling this, and we will be calling it's same b right, a right, and b right. There will be a comma. So if both of them are same, the same problem, then we can say yes, all trees are same. So for a tree to be the same, these two nodes should be equal, and the same problem we need to solve for the left child and the right child. So let's code it. If you have some doubt, it will get resolved as soon as I start writing the code. So don't worry. So let's say we have these two nodes. Now we need to check if p is equal to null and q is equal to null. Then return true. But if p is equal to null or q is equal to null, then return false. So in case any one of them is null, then it will gonna come here because both of them were null, then we're gonna return true. If any one of them is null, then we're gonna return false. In the else case, we will be returning. So if p val is not equal to q val, then also we can say return false. And then we just need to check whether the left subtree and right subtree are same or not. So if both of them are true, then only we will gonna say that this is same. Both of the trees are same. So here what we are checking, if both are null, then we are returning true. If any one is null, because one is null, one is not null, then we are returning false. If both were not null and values were different, both nodes were there, but values were different, then we are returning false. But if the values were same, then value is same, we need to check left and right subkey. So this is how. So let me submit this code. So we have got accepted. So we got accepted. Let me reset. Okay. So the test case got passed. So you can see the problem were very easy. And the main thing I like about lead code is here you can explore more problems. Let's say you want to work on trees, you can choose your topic. So first you need to just log in into lead code and then click on the problem section like this, and then you will be landing upon this page, and then you need to select difficulty level, let's say easy, and then let's say select trees. Then you will gonna get a lot of questions about tree, and then you can sort them in the order of acceptance. Based on the order of acceptance you can pick any question. Let's say we picked this one. So more the acceptance rate is, the it will be easier to solve. So this is how it works. So this is lead code platform. I usually recommend all of you to solve more and more questions for a particular topic based on your difficulty as well. You can choose your difficulty. If you want to solve medium level question, you can just click on medium. And there are like top favorite question as well. If you are preparing for interviews, then they just solve top interview questions and just remove the topic. You can just solve top interview questions. So I usually like interview bit. If you are really preparing for your interviews, you are in third year, then it's highly recommended for all of you. So if you have any doubts till yet, you can ask. We can even take different doubts based on your interviews and placements, and regarding your career as well. So guys, we can discuss doubts related to projects. We can discuss doubts related to your competitive programming and for GSOC as well. So just comment your doubts so that we can take it. So how do you get the intuition that problem lies in the part of algorithms? So before so we have a very generic question over here. So what I recommend all of you to prepare for interviews as well, and to improve your coding skills as well. There are 4 or 5 steps that I usually make as a roadmap. So first you must learn how to do you convert your logic into code. So You can just start solving very easy problems, and you just need to make sure that you are converting your logic into code very fast. So books, recommended books are very available, like Yashan Kanekar, which is usually already there in the part of curriculum of the colleges. Second step should be learning more about data structures. Let's say we just discussed freeze, and we just solved the easy question on lead code. You can solve more questions of the lead code as well, and you just penetrate into the discussion panel of the lead code. So if you are not able to solve it, there will be lot more code already submitted by the coders, which you can just read and check their reviews on it, check their explanation on it. You will gonna be learning so much faster, because you are working directly on the live questions, and it will be also giving you back like this test case got failed on the lead code for this particular problem. So lead code is very must for the second step. And the third step, I would be recommending all of you to learn algorithms more and more. So there is one book which I would recommend is Core Man. You can download it from the internet if it's possible, like if there is, or you can just buy it from Amazon. Secondly, there is a book which we have already forwarded in coding club groups, and it is called Algorithm Notes for Professionals. So this would be the third step that you need to work on. Fourth, I would be recommending you to work on projects. So projects, I recommend usually four projects. First one is working on machine learning. Though machine learning is very critical these days, and it's on in trends and hype. So machine learning should be included in your resume to create a very good hype for you. And secondly, you can also start working on, so second product recommendation would be backend API, working on backend API using Spring MVC Java, or you can take Node.js, you can take Django framework, whatever language you want to choose, and working on JSON API, REST API, these kind of projects. Second, that I would highly recommend to have in your resume. Thirdly, I would recommend all of you to have one Android project, so that if company is really interested for an Android developer, you can tap that particular probability as well. Because if you are just doing front end, or just doing back end, or just doing machine learning, you will be decreasing your probability to get placed, or the companies you will be targeting on. So this is my project recommendation for the fourth step. And fifth step should be working on making your own network, so that you can forward your resumes. So you need to be in touch with more and more alumni which are pass out from your college, or you just know them. So be in touch with them. So you must need to create a network around you, so that whenever you feel like I have been ready for interview, so you can just ask them for to forward, so increasing your probability chances to sit in off campus interviews. So these are my five steps that I just told. So I will just give you a quick overview. So first was logic into code. Second was data structures, working on data structures. Third was working on algorithms. Fourth was working on projects, and fifth we just learned was working on your own network, so that you can forward your resumes offline. So best source to learn machine learning. We already have shared a few books uh, on our WhatsApp groups, so you can check those WhatsApp links. And secondly, I would highly recommend you to work on one basic project, and you can check YouTube videos. And we are also coming up with internship come training program that will be under a flash sale. Our team will be circulating that, so don't worry about machine learning projects if you want to work on with under coding club. So more doubts we can take. So we will be showing you our coding mafia dashboard, and we will be celebrating successful coders who solved even 100 plus, 200 plus, and 300 plus questions within a time frame of 31 days. And we have even coders who solved 500 plus coding questions, including platforms, CodeChef, Interview Bit, and Lead Code. So these three platforms, few of the coders even have solved 500 plus questions. So I am gonna sharing my screen. Sorry. So you can also enroll whenever the flash sale comes. So this is our coding mafia dashboard, and we have 7 teams under it. So this is the round one result. So in the round one, Bhavya solved 80 plus questions within just week. So day one she solved. So this is a mentorship training program in which coders are able to solve more than 80 plus question, you can see. And even 61 question Saurabh solved in the first week, and Kritik solved 56, and he solved 55, 44. So you can see how many questions you can solve. And in the round two as well, he was solving 44 question, 31 questions. So 44 plus in the round one 80, it makes it 80 plus 44, which is around 124. And in the round three, he also solved some 6 plus 14, 15 questions. So including that, he crossed 140 plus the Saurav. And similarly, we have different teams, like Indigo team is there. In the Indigo team, we can see in the round one, he solved 51 questions. So in the coding mafia, it's all about a roadmap and timeline and mentorship, in which sessions are like this. For example, in the last slot, we had a timeline this like this. So round one happened, in which on the 10th March we had a live video session in which aim of coding mafia was given, and meet up with the instructors. And usually sessions happens from 8 to 10 p.m. Around, and each session is around 45 minutes to 1 hour to 1.15 hour. So on the 11th March, so every 2 3 days the instructor and mentors will be coming. And so was the round one roadmap. And each day you are given practice problems so that you can upload your details. For 12th March, how many questions did you solve? For 13th March, how many questions did you solve? For 14th March. So as soon as you start working on it, your graph will be generated so that you can track your progress. And this will gonna help you in increasing coding speed, confidence level, kickstart competitive programming, and cracking the coding interviews as well. So if you are in whether in your in first year, second year, third year, or fourth year, it doesn't matter, because all round are already, everything will be from scratch. And you can see in the round two we will be starting working on more and more. And so each round will have some different funda. So in the first round, we will be working on coding speed, and then we start working on different data structures and algorithms. And in the round three, we start preparing for interviews. So there are very great mix of mentorship program we have. And you can see lot more questions have been solved in the teams. So our team is alumni team is, so this is me, Rishabh, and she is Suruchi, Bhavna, Dhruv, Ravit, Pratik, Ashish, Sahaj, Tanuj. So all of these are the alumni team, and we have a mentor team, college mentors, and we have a team of 120 people offline in the Delhi. We have growth hackers. So you can also apply for these positions. We will be circulating soon on the groups. And if you are really interested for coding mafia, we will be having a flash sale on 13th, uh, and you will be able to take part in that flash sale for the coding mafia. So, guys, keep watching and keep coding. learn, inspire, grow. And if you have any doubts, you can just write a mail to us, contact@codingclub.tech. Goodbye, everyone. Learn, inspire, grow. Keep coding.